Yo, Physics Academic, welcome once again to the Simpkins Physics Corner. It's your host, Mr. Simpkins. Today, this is the lesson you've all been waiting for. How to pass physics class. All right? So, if we ask the Men's Warehouse guy, he's going to say, you're going to like the way your grade looks. I guarantee it. Before you start today's lesson, what I want you guys to do is go to our launch page on Canvas, Week 6 launch. You need to download the equation sheet. I have printed copies for you that I will give you when you get to class this week on our days. I want you to download the notes for today's lesson. You can do that by following the hyperlink there in Canvas. And then you should be watching this video, which we posted right there for you. All right, so before you go any further in this video, make sure that you have your notes so you can take notes along with us, and make sure that you have your equation sheet so you know what I'm referencing when I'm talking about. On your equation sheet, you will see all these magnificent equations, and they all have variables that mean things. You see, here in physics, I know it's 2020, but words mean things, and so do variables. And so if you look at all these variables we have, I want you guys to take a moment now. You can pause the video, and I want you to fill this in for your page there on page 1 of our notes. All right, all these variables mean things. So like XF, that means X marks the spot, X marks the position. X final, F means final, so final position. XF means final position. It's where you are at the end of a problem. And your location on our coordinate system is given in meters. So you could say, at the end of the problem, I'm 5 meters to the right of Mr. Simpkins. Right? That would be your final position. If you go down, XI, of course, means initial position. And then this thing, delta X, I actually want to write a little side note here, too. You can add this as well. Delta X is equal to X final, scratch that. Delta X is equal to X final minus X initial. That's one of the equations on your equation sheet. And all that means is that the change in X, remember that delta symbol means change in, the change in position is equal to final minus initial position. Now, if that sounds complicated to you, don't overthink it. If your final position is over here at 8 meters and you started at a position of 2 meters, how far did you go? Well, you went 8 minus 2, or 6 meters. 6 meters is your displacement. How far you went from this place to that place. Oh, we're going to get into it. I love it. Velocity is just in meters per second. It's how fast you're going, but it's also what direction. Because remember, V, velocity, is a vector. Speed is just how fast. Speed is a scalar, and that's measured in meters per second as well. All right, distance. The distance, if you're walking over here, and then walking over here, and then walking over here, and walking over here, every step that you take counts with distance. Remember, the difference between that and displacement is that displacement is just how far did I go from the starting position to the final position. Distance, every step counts. And then, of course, we have final time, initial time, and the change in time, delta t. All right, so you want to be familiar with what all these variables mean. You're not going to memorize this probably the first time you write it down, so I recommend making flashcards if you have a hard time figuring out which variables are which. But today I want to teach you the secret sauce of how to solve physics equations and how to have a very successful year and maybe even pass physics class. No, you'll pass physics class just fine, especially if you take this advice. First thing you want to do is you want to find the known pieces of information. So on your notes, if you go to page 2, it says step 1 right down there. Identify the known pieces of information. If you look at your notes, you'll notice if you go down under the step 1, 2, 3, 4, 5, let me pull it up here for you so you know what I'm talking about. If you look at your notes and you go down under step 1, 2, 3, 4, 5, you'll see this little problem about a boy named Billy, and that's the one we're going to look at today. So as you take your notes, write the step up here, like write what the step is, and then do that step down here in the Billy problem. So that's what we're going to do. We're going to write the step up here. We're going to do the step down here in the Billy problem as we go through. So the first one is identify the knowns. Well, it's telling us x equals 3 meters, x equals 5 meters, and something about 1 second. All right. So when you start a physics problem, the first thing you want to do is underline, box them, circle them, whatever. Find any numbers. I don't care how much physics you know or don't know. You're all functionally literate, which means you can tell the difference between a letter and a number, right? So go look for the numbers, find the numbers, and highlight those numbers. Make them obvious to you. Step 2, write this on the top of your notes. Write a list of knowns with variables and units. You see, once you identify these pieces of information that the problem is giving you, 3 meters, 5 meters, 1 second, okay, you want to write it in a list. And this is what we call our list of knowns. Now, if you look at my list of knowns right now, they are absolute garbage. Why are they absolute garbage, Mr. Simpkins? Why the harshness? Well, because that's not going to tell me which equation I need to use. Just looking at 5 meters, 3 meters, and 1 second doesn't help me figure out what equation I need to use. And that's the biggest question a lot of new physics students have is, what equation do I need to use? The thing is, the answer to that question is, it depends, which I know you don't like that answer. Too bad. That's what the answer is. If you look on your equation sheet under chapter 2, you will see these equations. All right, you'll see these equations. You got x final equals, v equals, all this stuff. All right. What you want to do is write the identifying variable with each of these. So let's go back for a second to that place where we defined everything. We defined all of this stuff right? And so we want to use those same variables to identify what this information is. You'll notice the problem, you can use context clues. It says you went from a position of 3 meters. All right, so if you went from, that's where you're coming from, that's where you started from. That's your xi, your initial position. And it says you went to a position of x final equals 5 meters. All right, what was his average speed for this? 1 second. 1 second's obviously measuring time. Now, look at the difference between this, numbers, I have no idea which equation to use, and this, which is, oh, I know what information I have in this problem. Way different scenario. Don't be lazy. Don't think you're too smart to write the knowns every time. Do it, all right? Because as things get harder, you're going to have this strategy to use. Let's go to the next step. Identify what you need to find. So write that in your notes there. Step 3, identify what you need to find. What we need to find here for this one is the average velocity. So now that I have my list of knowns, and I know that I'm trying to find velocity, all I have to do is take all these pieces, these known information pieces, and find an equation that has all that stuff and velocity in the same equation. All right, and when you go to your equation sheet, you'll find these two. This is step 4, identify the equation that includes the knowns and the unknowns. All right, so on your equation sheet, you have v equals delta x over delta t. But as a reminder, I just wanted to remind you guys that delta x means the same thing as x final minus x initial. You can go back to the table we started in to see that again. Okay, so I have my knowns, I have my equation. I love step 5. Step 5 is my favorite step because step 1 through 4 seems like a lot of work every time, but it's worth it because if you do steps 1 through 4 correctly, you will always get this last piece. Plug in the known information with the units and simplify. So we picked our equation. Here it is, x final minus x initial over delta t. I'm going to go ahead and plug in all my information. So you notice that the final position was 5. That's why 5 goes there. Initial position was 3. That's why 3 goes there. Time was 1. That's why time goes there on the bottom. And of course, you guys can all do that in your head probably. 5 minus 3 is 2 over 1 second. Your answer, 2 meters per second. Okay, now, could you have done this problem in your head? Probably, okay? But as we get to problems with these equations, you probably can't do those problems in your head. And so you need to have a problem-solving strategy, and that strategy is underline the knowns, write them in a list with the variables, identify the equation that has everything together, figure out what it's asking you for, and plug everything into that equation. So that is how you pass physics class. If that seems simple, which I hope it does, it is. Okay, it's really not that bad. It's like putting the pieces to the puzzle all together. Let's look at one more together here. Actually, hold on. We already did this one. This is Bill, or Billy. So we already did the Billy one. Let's look at this next sample one. This is not in your notes. That doesn't mean you're not allowed to write it. You can write it wherever you want. All right, or you can just follow along here. John can travel 5,600 meters in 1 hour. All right, and then it says, what is his velocity in meters per second? Oh, trying to get crazy here, Mr. Simpkins. Well, we can travel, so it looks like our delta x, that's how far we can go, is 5,600 meters, and our time here is 1 hour. Now, the problem with that is, as we noted earlier, we want our variables to have information paired with them that is in standard international units, SI units, and the SI unit for time is seconds. All right, and so what we need to do is convert that hours into seconds. So you may recall our annihilation strategy where we put, if hours are on the top, we put hours on the bottom. There are 3,600 seconds in an hour. That's I get from 60 times 60. And so this one actually isn't too bad. The time here would get us 3,600 seconds. So the question says, what is his velocity? Well, you look, we have delta x and we have t. So if we go to our equation sheet and it says, what is his velocity? Do you see how this problem-solving strategy helps us pick, oh, that's the equation I got to use. Velocity is displacement over time. Our displacement, how far we went from this place to that place in our journey, was 5,600 meters, and our time was 3,600 seconds. So if we divide 5,600 by 3,600, we're looking at 1.56 meters per second. So there's another sample. Same strategy. I underlined the knowns. I wrote them in a list with the variables. I chose I identified what I wanted to solve for, chose the equation that had that thing and the information I already know, and then I went and solved it. Here's what I want you guys to do for today. We have this last problem. What I want you to do is you can screenshot this slide, you can type it on Word, you can draw it on a piece of paper. This is what I need you guys to submit to me for the lesson today. So I need you to solve this problem. McRae's Tate starts 4 meters to the left of a tree and sprints to a position of 27 meters to the right of a tree in 3 seconds. What was her velocity? Now, remember our first lesson when we started this stuff was about coordinate systems. And so I'm going to draw a tree right here. There's a little tree, a happy little tree. Shout out to Bob Ross. If you start 4 meters to the left of the tree is our reference point. That's 0 meters. So I want you guys to think as you set this one up. If it's 4 meters to the left, what does that mean? Oh, negative 4 meters is our initial position. And our final position is 27 meters to the right of the tree. So use this picture, set up this problem. What I want you guys to do is write the problem down, the whole thing, underline the knowns, write your list of knowns, identify the equation, and solve for velocity. All right, next time I see you in the building, we will be doing some problem solving with speed and velocity. Otherwise, if you're doing asynchronous, we're going to talk a little about adding vectors together. So until the rest of the week, I'm Mr. Simpkins in the Simpkins Physics Corner.